Hi guys, Miss Moxley here for your Monday recording. Let me pull up the agenda here. Alright, so today you guys have Structure of the Sun lesson and Structure of the Sun quiz. Tomorrow you will be preparing for your Sun exam before you take your Sun exam. Wednesday we'll have our live session, and then you'll have the rotation and revolution lesson and quiz. Thursday you'll have your scrimmage. Your scrimmage is going to be the same format as it has been thus far. So you'll have 4 multiple choice questions, 2 extended response. 2 of the multiple choice questions will be review or from previous content, so any content from the beginning up to this point, and then 2 of the multiple choice, or the rest of the multiple choice, the remainder of the 2, will be from the new content that we've covered the past 2 weeks since the last scrimmage. Your extended response will also fall in this window of new material, so the material covered from the last scrimmage within the past 2 weeks. Please be sure that you're giving your extended response questions your best effort, so your best attempt. I want you to give some sorts of an answer. Please do not leave it blank. It's better to receive some points than to receive no points at all. And then on Friday, you guys will have the seasons lesson and quiz, and Mr. Wilson will be doing your notebook check. All right, so let's look at these objectives. So Friday, you guys completed Earth's formation and the sun. Your objectives for this lesson were to describe the basic structure of the sun. So you've been talking about the star in the past, so you should be a little bit familiar with nebula, star. We're going to talk about core, and you'll learn more about core today when you talk about structure of the Earth, and then photosphere. So let's go ahead, let's jump over to our conference page so that we can talk about some notes. So the sun. The sun is considered a star. It consists of mostly hydrogen and helium. It's been burning for 5 billion years, excuse me. It's been burning for 5 billion years and will continue, or is estimated to continue to burn for another 5 billion years. It is also responsible, for all life on Earth. It is the initial source of all energy and is the reason for day and night as well as seasons. So the sun is responsible for all of those things. Like I said, you guys are going to talk about, I see a typo. You guys are going to talk about the structure of the Earth today. So you'll talk about those different layers that creates the sun. But you will, or you should have, learned a little bit about the core of the sun, in that it is a nuclear reactor. Okay, and this core is about as dense as lead. It is gives off the most energy as far as the sun is concerned. This layer gives off the most energy. It is where hydrogen is converted to helium. So within the core, we've got hydrogen being converted to helium. All right, so like I said, you'll talk about the different layers today in your lesson, but you did talk about the core on Friday. Now, the sun, we said, was a star, and we have said that all stars are created from a nebula. So nebula was one of your vocabulary terms. So a nebula is a giant cloud of gas and dust which a star is born from. Oops. So the sun being a star, this is also how a star was formed. It was created from a nebula. Now the sun, even though it's a star, to us it looks very large and all other stars look very small. This has to do with the distance that the sun is from the earth. But actually, in terms of size, just to put it into perspective, the sun is about 109 Earths long. So if you were to put 109 Earths, if there were 109 copies of the Earth, and you were to put them side by side, it would take 109 Earths in terms of length to be as long or as wide as the sun is. So the sun is very large to us, but in all reality, in terms of its size, the sun is only an average size star. So there are other stars out there that are much larger than the sun. But for our solar system, the sun is the largest star within our solar system. It's also why we can see it, or we see it as the biggest star, is because it is so close to us. All other stars that are outside of our solar system appear much smaller because they're much further away. So because the sun is in our solar system, it appears much larger to us. Now, with the solar system, talking about the solar system, the sun is at the center of our solar system. So all of the planets in our solar system rotate around the sun. Now the sun has the largest mass. It is the biggest item within our solar system. Therefore, it has the greatest gravitational pull. This is why all of the 8 planets within our solar system orbit or rotate around the sun. So let's say the sun has the largest mass in our solar system. Therefore, has the greatest gravitational pull. Causing all the planets, to orbit the sun. All right, so the sun is at the center of our solar system. All of those planets rotate around the sun. And we've talked a little bit about our solar system and some of those planets. So you guys should all be familiar with that. But like we said, because the sun is in our solar system, it appears to be the biggest star to us because it's closest to us. And this distance is called relative distance. And because of this relative distance, this relative closeness, it also appears to be brighter to us. So the sun appears to be brighter. Relative distance, or the distance that any star is from Earth, we call this absolute brightness. So this distance, this relative distance from Earth, so from where we're standing, from where we see it, affects the absolute brightness of any star. So how bright a star is to us on Earth is affected by this relative distance, how far or how close the star is to us on Earth. So let me just say that again in case anybody was to get confused. Absolute brightness, the brightness of a star, so how bright we see a star, is determined by the relative distance. So how far or how close a star is to us will impact just how bright it is to us. So the closer it is, the brighter it will be. So to sum things up, to wrap things up for you guys, without the sun, Earth would be lifeless. We would not have our solar system that we know, all 8 planets that orbit that sun. We would not have day and night. We would not have seasons. We would not have any of these things. So without the sun, life we know it would not exist. We would not have day and night. We would not have seasons. We would not have this initial source of energy, this energy that thrives and prospers or makes all life prosperous. So the sun being the initial source of energy, all life uses that energy in some way, either directly or indirectly. We would not have our solar system in terms of our planet Earth orbiting around the sun, all of those things. We would not have any of these things without the sun. All right, so for today, like I told you guys earlier, you're going to learn about the structure of the sun. So you're going to learn about those different levels, those different parts of the sun. All right, I want you guys to make sure that you're taking your notes home this week to study for that sun lesson exam. If you have any questions between now and then, please don't hesitate to reach out, and I will see you guys again on Wednesday for your live session. Bye, guys.